Hey class, today we'll show you how to start the course project and based on the virtual lab provided by Mathwork. Okay, so first open the project description and then it provided a link that go to the web page that you can download the virtual lab. So you can copy this link or directly click on that link. It will lead to you a GitHub web page where you go to the code. So click on the code and then download the zip file, and then you will download the virtual control lab. And then go to the files. So in my case, it's in download. So it's a zip file. So we need to extract the file, and then I will extract it in the same folder. Take a few seconds. Once it's unzipped, it will open. It will name that as virtual controls laboratory main, and then you can close, open, and open. What we'll use is a virtual controls laboratory.prg project. So we'll open this while MATLAB. So next step is open MATLAB. Click on tab open and go to the path where we downloaded and find the virtual controls lab.project. Click it and open it. So once opened, that it will provide instruction about the virtual control lab. Take some time to read through it. And what we'll use is we'll work on lab 3 and lab 4. And lab 4 is to work on a virtual DC motor. This DC motor, you can open this DC motor through the link here. It's dcmotor.slx. Click on it, and you will see the virtual DC motor. So you can click on this DC motor, and it's a system that with a DC motor and then coupled with a gearbox with a ratio 9:1, means that by slowing down the speed through the gearbox, we generate a bigger torque to drive the external system. And the ratio is 9:1. And don't change any parameters to the motor and this gearbox. So just close it. Here I will show you that how to provide input and generate output and the starting point for your project. So now we have this motor and gearbox. We can provide the input. The input will be voltage, and it will generate output. The output is rotation and measured by angle degree. So we can put the input to the system. We click on the library browser and open this Simulink block diagram. We use sources. We can input let's put a step input to it. And again, we want to look at the output. Go to the commonly used blocks. Find the scope, right? And then we use the step as the input, and the degree. We'll look at the rotation in terms of angle, which will show down the scope. So you can change the parameter for the step input. By default, the step time will be 1. That means in terms of time, from 1 to 0, the voltage is 0, and then after 1, and then voltage will become 1. Okay, and then we can run the simulation. The stop time we can set as 5, and then we run it. When you run it, it will show how this gearbox rotates. And you can also check this result here by double click on scope. You will see that the DC motor will rotate when there's a voltage at time is 1, it's continue rotating, the degree will continue increase. Okay, and this video serves as instruction how to start your project. So, and then later you will work on 2 parts for this project, figure out the transfer function and then of the system, and then use a closed loop system to set up position control, use a DC motor, and then use the PID controller or lead lag compensator to optimize the position control system by reduces response time, steady state error, and overshooting. Okay, we'll stop here.